Welcome to today's math lesson on partial quotients. Today's learning target: I can divide a larger amount into smaller equal-sized groups using the partial quotients method. Now, before we begin, there are two things I want to mention. First, do you have your math notebook? And if you don't, go get it. And today, I'm going to have you set it up like this. Okay, do you see this page? I've oriented the page as a landscape. Along the top, I have my name, and then I have 4 columns, right? Column 1, 2, 3, and 4. And in each column, I'll solve one problem today. And this is where you're going to do all your work. So go ahead, pause this video, and grab your notebook, set it up just like this, and I'll meet you back here when you're done. Go. Okay, welcome back. The second thing I want to point out is this. This is an image of a partial quotients problem that is going to be on every single slide that we work with today. And I want it here for you as a visual reminder of what partial quotients looks like as we're setting up and working through these problems, okay? You can use it as an example if you want, I suppose, but really it's just meant to be a visual reminder of what partial quotients looks like as we work through the problems. So let's get a little deeper into that right now. Before we start, let's review, okay? Here we have a visual model of a dividend, and that dividend is 6, right? 1, 2, 3, 4, 5, 6. That's the large group. Now, what if I said, let's divide 6 into 3 groups. This is our divisor, 3. And that, I hope, would sound very familiar because that is how I've been teaching you what division is for the last few days. And hopefully you'd say, oh, wait, 3 groups. That's 1 group, 2 groups, 3 groups. And so the quotient would be 2 because there is 2 squares in each group. I hope that sounds familiar. Now, we need to think a little bit more flexibly about division, however, before we start partial quotients, because there's actually another way to think about division that's just slightly different. It's virtually the same, but it's just different enough that I need to mention it, okay? Because it will lead right into partial quotients and how we think about it. So what if I said, let's take this dividend of 6, okay? Same dividend. And we're still going to divide by 3. That's our divisor. But now we think about the divisor as like this. How many groups of 3 are there in 6? Well, I haven't written anything new, have I? Without changing the number sentence. If I ask the question that way, how many groups of 3 are there in 6? I could say there are 2 groups of 3. And look at that. The quotient is still 2. So you can think of division both ways. They're so similar. You don't even need to change the numbers because everything, the dividend, the divisor, and the quotient will always remain the same. It's just a matter of how you think of it. And so for partial quotients, we're going to be thinking about division in this second way. How many groups of a number, such as 3, are in our dividend, such as 6? I think this will make more sense with our first example. Here we have 73 divided by 6. 73 divided by 6. And here we have our visual model just to remind us of how partial quotients looks when we're done and working through a problem. Okay, so you'll notice the first thing we do is in partial quotients, we draw a line right down the right-hand side like this. Okay, super important. You want to draw it as nice and straight as neat as you can. Okay, and now what we're trying to do is we're going to divide 73, but we're going to do it by asking ourselves, how many groups of 6 are in 73? Now, luckily, these numbers are fairly small. So in this case, we can actually use our reflex math facts. Thank you, reflex math. Let's see. I know that 6 times, let's see if we can get close. I know that 6 times 10 is 60, right? 6 times 10 is 60. And 60 is pretty close to 73, but let's see if I can get closer. 6 times 11 is 66. That's closer. 6 times 12 is 72, right? 6 times Wait, 72 is really close. Let's just keep going though. 6 times 13. What is that, like 88 or something? That'd be too big. Anyway, 6 times 12. 72. That gets us really close to finding out how many total groups there are in 73, because 72 is really close to 73. So here's what we do. Okay, we're going to write our partial quotient over here to the right side of this line, right here. Okay, so I just found out by using my reflex math skills that there are 12 groups of 6 in 73. So that's my first partial quotient. In this case, it might be my only partial quotient, but I'm going to write it right here. And then what I'm going to do is I'm going to write a line that goes in a nice straight way underneath the 12 and right across almost to the 6. Because what I have to do next is I have to multiply 12 times 6, which I've already done because I was thinking, well, what is 6 times 12? And I got 72. And I'm going to write that product underneath the number I'm dividing, okay, which is 73. And I'm going to make sure that my place values stay nice and lined up. My ones places, my tens places, they got to stay lined up because what I'm about to do is subtract. 3 minus 2 is 1, and 7 minus 7 is 0. So I have 1 left over. And now I'd repeat the same process. How many groups of 6 are there in 1? Well, there are none. I can't pull $6 from $1. So I'm done. This 1 is what we call a remainder. It's what's left over when I'm done making equal groups. And so the way I report that is by writing r, lowercase r, 1. So now we have our quotient, 12, remainder of 1. There are 12 equal groups of 6 in 73. And in partial quotients, what we do is we take our quotient, our total quotient, and we write it up here on the answer line using our place values, okay? Let me go with red for answers today. 12, notice my place values are lined up, right? The tens places, the ones places, very important, with a remainder of 1. That is our final total quotient. And that is how we do partial quotients. Let's look at a bigger example here. Let's look at 313 divided by 9. Now, the numbers might be bigger, but the steps are the same. Okay, step 1, we're going to draw a nice straight line down the right-hand side of this problem, straight as we can. Now, we're going to ask ourselves, all right, how many groups of 9 are there in 313? Whew. Now, I can't use my reflex math facts for that because 9 times nothing I'm learning in reflex gets me close to 300. But do you know what we can use to help us solve a problem like this? It has to do with the lesson we learned a couple weeks ago. Yes, extended math facts. And so what we're going to do now is we're going to work up here in this right corner, okay, up here. And I'm going to come up with some really handy, helpful extended math facts that are going to help me solve this. I'm always going to start with a nice, easy, round number that I can multiply my divisor by. And you know what that number is? 10. 9 times 10. I know that. That's 90. So I'm going to write really quickly in the corner a nice little list. 9 times 10 is 90 is the first item on this list. Now, is 90, I ask myself, close to 313? Not really. I think I can pull more groups of 9 out of 313. So what I'm going to do is continue this list. I'm going to do 9 times 20. What's 9 times 20? Do you know? Well, 9 times 2, that's 18, plus 1, 0, 180. Is 180 close to 313? Yeah, it's closer, but I think we can get even closer than this, can't we? Let's do another one. Let's do 9 times 30. Well, 9 times 3 is 27, plus 1, 0 is 270. I told you these extended math facts were going to come in handy. Now it's 270 close to 313. So what are we going to write over here in our partial quotients line? Do you know? Yep, you got it. We're going to write 30. 30 groups of 9. That's our first partial quotient, our first part of the answer. And now we're going to multiply 30 times 9, which we've done right here. So I can just copy this product, 270, underneath the 313. And I'm going to make sure my place values are lined up. Yes, they are. And I'm going to write my equal sign underneath the entire step. And I write it underneath the 32 So I can see that this 30 goes with this 270. This is the product from this partial quotient and my divisor. It's all under one line, and I'm going to subtract. So let's do it. 3 minus 0 is 3. 1 minus 7. Can't do that. I'm going to have to borrow. 11 minus 7. Well, that's 4. And 2 minus 2 is 0. So 43 is what I have left over. Now we repeat the process. Now we ask ourselves, how many nines, groups of 9, are there in 43? And here's where reflex math can come in handy, right? Because now I know, let's see, 9 times 3 is 27. Yeah, 9 times 4 is 36. 9 times 5 is 45. That's too big. That's too many nines. So I'm going to go with the one just below that. 9 times 4 is 36. So I'm going to write my next partial quotient underneath here. 9 times 4. Notice I even kept these place values lined up, because in a second, I'm going to have to add these numbers together. I'm going to do 9 times 4 is 36. I'm going to write that underneath the 43, and I'm going to keep my place values lined up just like that. Look at how pretty that looks. Yeah? I write my equal sign under the entire step and my subtraction symbol as well. And now I'm going to subtract. Let's see. 3 minus 6. Can't do it. Got to borrow from the 4. 13 minus 6. 7. 3 minus 3 is 0. I have 7 left over. How many groups of 9 are in 7? There are none, aren't? Nope, can't do it. 7 has to be a remainder because I can't pull another whole group of 9 if I only have 7 left. So I now have 2 partial quotients, a 30 and a 4. And the last step here to get my final end quotient, my final answer, is to add them together. All right, so part of the answer is 30. That's a partial quotient, part of the answer. And the other part of the answer is 4. When I add them together, I get, let's see, put your addition symbol in there. I get 34 with a remainder of 7. So lowercase r, 7. And I'm going to move this answer right up here to my answer line. I'm going to keep my place values lined up. 34, remainder 7. And notice my place values are lined up. Notice my place values are lined up. Wow, my writing neat. Check this out. Everything's lined up perfectly. Look at that. Oh, okay. That's how you do it. One more practice, then you're going to get to work on your own, okay? You're going to help me with this one. All right, I'll set it up for you. We're going to go ahead and draw our nice straight line down the right-hand side. Now, what would you use? What would you use as your first partial quotient? Go ahead and figure out what your best first partial quotient would be. And then meet me back here on the other side, and let's see if yours matches mine. Go ahead. All right. Well, 649 divided by 11. Okay, well, this is definitely not a reflex math fact. So let's just start thinking about groups of 11. I know that 11 times 10, now this is a reflex math fact, that's 110. 110, though, it's not that close to 649. I think I could pull more groups of 11 out before I start subtracting here. So I'm going to do another extended math fact, 11 times 20. Well, let's see here. 20 is double 10, so my product should be double 110. Or I could think of it this way. 11 times 2 is 22. With 1, 0. 220. Getting closer. How about 11 times 30? Well, let's see. That'd be 11 times 3 is 33 and a 0. About 11 times 4? 40. That'd be 11 times 4 plus a 0. 440. Now, 440. Boy, 40 groups of 11 is getting closer to 640, but I think I could get even closer than that. I'm going to go for 11 times 50, which is really just 11 times 5 is 55 with a 0. Ooh, I like it. 550. I'm going with it. I'm going to start here. 550 groups of 11. 550 groups of 11. Oh, no. Sorry. No. Ignore me for the next 10 seconds. Of course not. I'm going with 50 groups of 11. 50 groups of 550 is the product. It's the value of 50 groups of 11. Boy, I'm tired. Sorry. So I'm going to write 50 groups of 11 here. And I'm going to put my equal sign underneath, my subtraction sign. I know that 50 groups of 11 is 550. I've already multiplied. So all I have to do is bring it over here, right? 550. I'm keeping my place values lined up super careful so I can subtract correctly. And now I'm going to do that. 9 minus 0 is 9. 4 minus 5, got to borrow. 14 minus 5 is another 9. 5 minus 5 is 0. Let's repeat the process. How many groups of 11 are there in 99? Wait a second. Oh, thank you, Reflex Math. This is a math fact. It's 9. 11 times 9 is 99. I can use 9 as my next partial quotient. Here's my equal sign underneath everything. Subtract. I'm going to do 9 times 11. That is 99. And that gives me a remainder of a zip. Zilch. Nada. Nothing. 0. Yes. So let's go ahead and add up our two partial quotients. 50 plus 9 is 59. This, it turns out, is our final quotient, our final answer. So let's move it up to our answer line. Let's keep our place values lined up. And if everything looks good on your paper, all of your place values should be lined up. All the ones, all the tens, everything, the whole time, all the 100s. That's how carefully you should be working. And this is how partial quotients works. Are you ready to try some on your own? All right, let's do it. You have 3 problems to do plus a challenge problem that's optional. I want you to try the first 3 problems, numbers 1, 2, and 3. But when you get to problem 4, it'll say challenge, and that's optional. If you don't want to do it, just write the word pass in the answer box in Edpuzzle, and I'll know that you chose not to do it, and it won't count against you. Okay? So go ahead, do this problem, write the answer in the answer box in Edpuzzle, move on to the next problem, and repeat the process until you're done. Let's do this. Let me know if you need help. Good luck. All right, you ready to go on to the next one? Let's do it. Okay, you ready to go on to the next one? Doing a great job. Keep up the good work. Okay, that was your last problem, unless you want to try the challenge problem. And here it is. You're done. Thank you for working so hard. And let me know if you need any help on anything. Okay, goodbye.